So now we're going to talk about anions, which, as I said before in the previous video, they're basically seen as the opposite of cations, and you're going to see the reason why. So let me make this larger first, and then, okay. So if you have a situation where one or more electrons are added to an atom, then the resulting structure will have a negative charge. And it's a negative ion, and we call that an anion. All right, so the anion is a negatively charged ion, while the cations that we discussed previously are positively charged. So just to give you an example, if we start off with the chlorine atom has 17 electrons and 17 protons. All right, being a neutral atom, that's a situation. Number of electrons equal to the number of protons. Now the chlorine atom can end up with an additional electron, and when that is added, the resulting structure will have now 18 electrons and 17 protons. So therefore, because you have one more electrons compared to the number of protons, then the overall charge on the resulting structure will be negative. So we end up with what is known as the chloride ion. So this is going to be our anion in this particular case, right? So that's basically what happens when you have the formation of an anion from an atom. Basically, you add electrons to the atom and you end up with your negatively charged species. And just as in the case where what we talked about earlier, where we said that the number of electrons being lost from an atom is dependent on the position of the element in the periodic table, the same is true to a certain extent when it comes to the anions in terms of the number of electrons gained. But I won't go into all that discussion right now. It's just enough for you to know that basically the number of electrons, or when electrons are added to the structure, the resulting structure will be an anion which carries a negative charge depending on the number of electrons that is being acquired by the atom. So how do we go about naming anions? Now, in the case of naming anions, it's a bit different from how we name cations, because if you remember, we said when you're naming anions, when you're naming cations, you simply take the name of the particular element and that's it, right? Sodium ion, magnesium ion, and so on. In the case of anions, it's a bit different because the rule says an anion consisting of one element has the stem of the parent element and then it ends with IDE or IDE, all right? So basically it's a combination. The name of the anion is a combination of the stem of the parent element name and then the IDE ending. All right, so we're going to see a few examples of this right now. So for example, the ion that is formed from the element fluorine, right? The name of that ion is the fluoride ion. So you see this part here, the stem, right? That comes from the fluorine and then the IDE ending, all right? And that is basically what you're going to see in this and other examples, such as chlorine, right? So the anion formed from the chlorine atom is called the chloride ion, right? The stem, chlor, from chlorine, and then IDE. The atom formed from the bromine atom is called the bromide ion, all right? The atom formed from the nitrogen atom is called the nitride ion. The atom formed from the phosphorus atom is called the phosphide ion, and so on and so forth, right? Oxygen will produce the oxide ion. All right, so basically that's how we name anions. So it's a slightly bit more complicated compared to naming cations, right? You have to take the stem of the name of the element and then it ends with IDE. Okay, so let's talk about the formation of an ionic compound, right? As stated here, ions are always formed by the addition or removing of electrons from an atom, all right? And most often ions are formed when you have a combination of metal and non-metals, right? And if you remember, we said earlier, the metals tend to be found on the left side of the periodic table, the non-metals tend to be found on the right side of the periodic table. So therefore, when you have an ionic compound being formed, it is formed usually between metals and non-metals, all right? So I referred to this before. The charge on an ion can be, to some extent, be predicted from its position in the periodic table. And this diagram here basically gives you a sort of guide as to how the charges on the ions are related to their relative positions. But this is not universally true for all elements, but true for elements in certain groups, such as elements in group 1A, elements in group 2A, elements in group 3A, right? Basically, the charges that are formed would be equal to the group numbers. And then now, in the case of elements in group 5A, 6A, and 7A, you'll notice that some patterns here. For example, elements in group 7A, they tend to form ions with a -1 charge. Elements in group 6A, they tend to form ions with a -2 charge. And elements in group 5A, they tend to form ions with a -3 charge, right? And that's pretty much all we can say in terms of correlating the group numbers with the charges that the ions would form, because apart from that, it is simply not a simple exercise in prediction of the charges that certain elements will have, all right? Okay, so let me get to here. This is what I want to get to. How do we write the formulas based on the names of the ionic compounds and vice versa, all right? So basically, the key thing that you need to keep in mind when determining the ionic compound formula is that the total charge of the compound must be 0. So what does that mean? That means that the total number of negative charges must be equal to the total number of plus charges, all right? That is basically a rule that you must adhere to in order for you to get the correct formula for an ionic compound, right? So I'm going to show you how we do that using these examples right here. So the first of these three here is calcium chloride, and you're asked to write down the formula for calcium chloride. So this is the way you go about it. Now, you should remember that I've provided for you in Canvas a table, all right? That table will give you the list of ions and their charges, all right, among other things. So that is a table that you'll be referring to in order to, in order to answer questions such as this. So let me see here. I'm trying to find my, all right, let me use this writing pad right here. Okay, so the first one is calcium chloride, all right? So when you go to the table, you're going to look up the formula for the calcium and chloride ions. And you'll notice that the formula for the calcium ion is Ca2+, while the formula for the chloride ion is Cl-, all right? So the next step is, as we said before, to ensure that the number of plus charges will be equal to the number of negative charges. Now you'll notice that that is not the case here. We have a 2+ charge here, and we have a -1 charge here. So what I would do here is multiply this here by 2. So by doing that, we now end up with a total of 2 negative charges, which will cancel out the 2 plus charges, all right? So the result of that is, when we put this together, the final answer would be CaCl2, and that would be the final answer as far as answering the question as to what the formula of calcium chloride is, all right? So that's basically how that is done. The next example, they gave us barium phosphide, all right? So again, we go to the tables and we look up the formula for the barium ion and the formula for the phosphide ion, all right? Again, we have to ensure, just as we did in the previous example, we have to ensure that the number of plus charges must be equal to the number of minus charges. As it is right now, that's not the case, because we have a +2 here and we have a -3 here. So to get the charges equal, what I would do is multiply this by 3 and multiply this by 2, right? So 3 times +2 gives you +6, 2 times -3 gives you -6. So therefore, when you put this together, the final answer becomes Ba3P2, and that would be the formula for barium phosphide, all right? Okay, the last example is magnesium oxide. And it turns out that this one is the easiest one. Why? Because magnesium, if you look it up, the formula for the magnesium ion would be Mg2+, and the formula for the oxide ion would be O2-. As it is, the number of plus charges is exactly equal to the number of negative charges. So we don't need to multiply the magnesium or the oxide ion by anything. So all we have to do is just put them together, and the final answer would be MgO as the formula for magnesium oxide, and that's it, all right? So as you can see, it's a relatively simple exercise in terms of determining what the formula is based on the name of the compound, of the ionic compound. Okay, so let me see here. I think I'm going to stop here for this video, and then we're going to continue discussing naming ionic compounds based on their formulas, all right, which is the reverse. Okay.